Okay, hello everyone. So today our lesson is about O-level chemistry, and the name of the chapter is acid, base and salts. Okay, so let's begin from the start. Now, interestingly, one amazing fact is that suppose this is a hydrogen atom. Okay, um, okay, so here we go. This is a proton, a positive charge, and here is an electron, the negative charge. Now when you take out this electron from over here, now what you get is something like this, okay, that contains only the proton with the outermost shell empty. Okay, so here this is the hydrogen atom and this is the hydrogen ion. Okay, all right. Now the hydrogen ion in biochemistry or in biology has got many important facts and many important issues. Okay, so hydrogen ion is very important in considerations of biology, chemistry and many things, because hydrogen ions or the presence affects many reactions inside our body, affects many conditions of living things. So the consideration of hydrogen ion is important both in terms of biology and chemistry. Okay, both, in case of both, the consideration of hydrogen ions are important. All right. Okay, now how does hydrogen ion affect the biochemical reactions? Okay, let's see. Like if your blood, let me give some example. If your blood contains a lot of hydrogen ions, then what will happen is that your breathing rate, I am writing in short, your breathing rate will increase and you will start to breathe very fast, and your many enzymes of your blood will be destroyed. Okay, so again the opposite will happen if there is a very small amount of hydrogen ion in your body. Okay, so acids, base and salt, all the whole chapter deals with the matters which involves the hydrogen ions. Okay, so let's now discuss about acids at first. So what are called acids, or what substances we call acid? Please start writing the note. Okay, so acids are substances which are defined entirely in terms of hydrogen ions. Okay, so two definitions are given by two different scientists at different times. First of all, scientist Arrhenius said that anything that can release hydrogen ions or H plus ions when dissolved in water. Anything that can release hydrogen ions when dissolved in water are called acids. Okay, so this is the Arrhenius definition of acid. Please don't stop writing the note. I will tell you when to stop. And another scientist known as Bronsted and Lowry, you don't have to write the name of the scientist. Bronsted and Lowry said anything that can give hydrogen ions to others. Anything that can give hydrogen ions to others are called acids. Okay, so these are the two definitions of acid. Anything which release hydrogen ions when dissolved in water are called acids, or anything that gives hydrogen ion to others are also called acids. Okay, please don't stop writing the notes, carry on writing. Okay, now some examples, let me tell you. For example, we have HCl plus H2O. So when HCl reacts with H2O, it seems that it becomes Cl minus and H3O plus. Okay, let's see. Look here, it was HCl, but here it's Cl minus. That means one H is lacking, isn't it? So here it was HCl, here it is Cl minus, so one H is lacking from here, and here it was H2, but here it is H3. So here there is one H more. That means what can we say is that the HCl has given a hydrogen ion to H2O, so that it became H3O and a plus. Okay, so that means HCl is the hydrogen ion giver, so we call it acid. Okay, and H2O is a hydrogen ion taker, so we call it a base. Okay, so what is an acid? An acid is anything that can give hydrogen ion to others are called acids. Okay, and what are bases? Bases are something that can gain or accept hydrogen ion are called bases. Okay, stop writing the notes. Now let's go into some more discussion. Okay, so acids are basically, they are hydrogen ion, they are hydrogen ion givers. Okay, acids are hydrogen ion what? Givers or donators. Okay, so these are the acids, those who can give or donate hydrogen ions. Okay, and bases are the hydrogen ion takers, or we can say acceptors. Okay, so now let's see some examples of acids and bases. Let's look at an example over here. I'm writing H2O. No, I'm writing H2SO4 plus, I can write O2 minus. All right. Okay. I'm giving a blue arrow, meaning that a reaction is occurring to produce SO4 2 minus and H2O. Okay, now look at here. Okay, here it was H2SO4, but here it is SO4. So from here to here we can clearly see that 2 hydrogen is lost. That means 2 hydrogen ions are lost. That means this this whole compound has given off 2 hydrogen ions. So this is the acid, isn't it? So this is the acid. Okay, ACID, acid. Now look at over here. This was O2 minus, that means only oxygen or oxide was here, but here it is H2O. So that means this oxide has gained 2 hydrogen ions. So this oxide is a hydrogen ion gainer, so we would call it a base. Okay, base. So these are acids and bases. Now let's look at some more examples of acids and bases. For example, I'm telling HNO3 plus OH minus. Okay. Next, what happens is that I'm telling that it becomes NO3 minus and H2O. So okay, let's look at again what's happening over here. Okay, so this is HNO3. I don't like the color, by the way. Okay, so this is HNO3. Here H was present, but here this is only NO3. That means H is absent. That means this compound has given off the hydrogen ion. Okay, so this compound will be known as an acid. Okay, now what about this compound is that, look, here it was OH, that means one oxygen and one hydrogen, but here it is H2O, isn't it? That means it has now two hydrogen but one oxygen. That means from here to here it has gained one hydrogen. So this is a hydrogen ion gainer, for which we will call it a base. Okay, so these are the acids and bases. Okay. Now let's look at the identifications of acids and bases. Some examples of acids and bases that we are going to deal with in this chapter. So first, let's look at acids. Okay, so acids are we will learn to know that, oh, so much thick. Okay, so HCl means hydrochlor. Okay, start writing notes from here. So now some examples of acids. HCl means hydrochloric acid. H2SO4 means sulfuric acid. HNO3 means nitric acid. H3PO4 means phosphoric acid. Okay, so HCl is hydrochloric acid, H2SO4 is sulfuric acid, HNO3 is nitric acid, H3PO4 is phosphoric acid, and any acid that contains COOH group, these are called the carboxylic acids, and these are the organic acids. Okay, so let me shade the hydrogen ions, I mean the parts that's going to get off as hydrogen ions. Let me shade those parts. Okay, H, okay, okay. So these are the parts that are going to be released off as hydrogen ions. Okay, and now here we will deal with some few kinds of bases. Okay, so let's talk about bases. Bases. So what are the bases? Number one, O2 minus. Any compound that contains the O2 minus, that means the O2 minus is the base, which is known as the oxide. Okay, O2 minus is the base, which is known as oxide. Okay, so for example, you can say magnesium oxide, any metal oxide, metal oxide. Okay, okay, and this is called the hydroxide. Okay, so we better say metal hydroxide. Okay, and CO3 2 minus. This is the carbonate, okay, where we can say the metal carbonate or positive ammonium carbonate, etc. So whatever it is, the oxide ion, the hydroxide ion, and the carbonate ion, these are the three bases, okay, that can take the hydrogen ions. All right. So these are the types of bases and these are the types of acids that we are going to deal with in our O-level syllabus. Okay. Now stop writing the notes. Okay. So let's look at the reaction between acids, the reaction between hydrogen ions and different types of bases. Okay, we will have a look at the reaction between hydrogen ions and different types of bases. All right. Okay. So first of all, look at the valency of hydrogen ion. The valency of hydrogen ion is +1. All right. Okay. So now look at the valency of O2 minus. So what is the valency? It's 2 minus. So for chemical reactions to occur, the valencies must be balanced or must be equal. Okay, OH minus, it has got a valency of -1, and CO3 2 minus has got a valency of -2, just like oxide. Okay, so how does hydrogen ions react with these bases? Okay, start writing the notes. Okay, now for example, hydrogen ion and O2 minus ion. So what is the valency of hydrogen ion? It is +1. And what is the valence of oxide ion? It is 2 minus or -2. So this is 1, this is 2. So these are not equal. So we must take 2 hydrogen ions to make it equal. Okay. So that's why we are taking 2 hydrogen ions, and these 2 hydrogen ions will be gained by the oxide ion to form H2O. Okay. So this is the reaction between hydrogen ion and oxide. Now now H plus will also be gained by the OH minus. Okay, here the valency has matched. It is -1, it is +1. So the valency has matched. So simply they would also form H2O. Okay. And thirdly, okay, H plus CO3 2 minus, they would form. Okay, so what is the valency over here? It is also 2 minus, but hydrogen has got +1, so you need 2 hydrogen ions to balance it. So that 2 ones are 2, so +2 and -2, it's not balanced. Okay, now what happens is that take 1 oxygen out from here and put it with hydrogen ion. Okay, so it forms H2O. So 2 hydrogen from here and 1 oxygen from here forms the H2O. Okay, and then so what we are left with here, there were 3 oxygen atoms, but one oxygen has got out and has taken 2 hydrogen ions from here. So if 1 oxygen gets out from here, we are left with 2 more oxygen atoms, so it forms CO2. Okay, so these 3 reactions are very important in terms of acids and bases. Okay. Okay, so over here, no, so these are the 3 reactions of the hydrogen ions with the bases. Okay, stop the note. Okay, now let's define the term called alkali. Okay. Okay, so what are alkalis? Okay, so alkalis, they are bases that contains hydroxides. Okay, so alkalis are bases that contain hydroxide, number one, and number two, the alkalis must be soluble in water. Okay, so these are the two important properties of an alkali. And number three, they must feel slippery to the skin, just like soap. Like when you touch a soap, your skin becomes slippery, right? So alkali on your skin should cause your skin to go slippery. Okay, start writing the note. So alkalis are bases containing hydroxide. Okay, so alkalis are simply hydroxide containing bases which are soluble in water and that would feel slippery to our skin. Okay, all right, so these are the alkalis. Okay, now how will we identify acids and bases? Okay, so let's leave it for a practical. After the coronavirus era ends, we will begin our practicals. Okay, so identifying acids and bases. First, we are going to know about the fact which is the pH, or pH means actually the presence of hydrogen ion, okay, or the pressure of hydrogen ion. Okay, pH are some numerical values that would tell you that whether huge amount of hydrogen ion is present or not. But before going into pH, you must be able to know something, that a solution is acidic. Okay, a solution is acidic doesn't actually mean that it contains only released hydrogen ions. Okay, this is not the fact. Uh, or a solution is alkaline. Alkaline does not only means that it contains only hydroxide ions. Okay, then what is the actual meaning of acids and alkalis? Okay, so you must keep in mind, please start writing the note from here. All solutions or all acidic, or all aqueous solution, all aqueous solution, that means solution containing water, all aqueous solution contains both hydrogen ions and hydroxide ions. Okay, all aqueous solution contains hydrogen ions and hydroxide ions. Okay, now if amount of hydrogen ion is greater than the amount of hydroxide ion in the solution, we would call it acidic. Okay, now if the amount of hydrogen ion and amount of hydroxide ion, if the amount of hydrogen ion and the amount of hydroxide ion, they are equal, we would call them neutral. Okay, and now if the amount of hydrogen ion is less than the amount of hydroxide ion, then we call it alkaline. Okay, so these are the natures of acidic, basic, neutral and acidic, alkaline and neutral solution. Okay, so acidic solution. So inside the like in the acidic solution, we have more hydrogen ions than the hydroxide ions. In neutral solution, we have equal amount of hydrogen ion and hydroxide ion, and in alkaline solution, we have greater number of hydroxide ions. All right. Okay. So you may stop writing the note. Okay, you know that I've told initially that pH values range from 0 to 14. Okay, and I have also told that a solution contains both hydrogen ions and hydroxide ions, but whether the solution is acidic, basic or neutral depends on the relative amount of the ions present. Okay, let me give you a chart. Just put since the pH values range from 0 to 14, just keep this in mind that we will imagine it in this way, that total amount of hydrogen ion and total amount of hydroxide ion would add up to give 14. Keep this in your mind. Okay, and pH value we will take as the amount of hydroxide ion. Just keep this in mind. Okay, these are the things that you need to memorize it. Please note this part down. Okay. Okay, this says pH, but we will record OH. Okay. So tell me, for example, if hydrogen ion, and okay, this is the hydroxide ion, and okay, this is the pH. Okay, now if hydrogen ion has got the amount 0, then hydroxide ion must be 14. Okay, because the total has to be 14, so the pH would be 14. Okay, that means this solution contains a large amount of hydroxide ion, so the solution is alkaline, strongly alkali. Okay, now suppose the amount of hydrogen ion is 3, so the amount of hydroxide ion would be 11, so the pH would be 11. Okay. Okay, so this solution is still alkaline, but it is a weaker alkali than the last one, isn't it? Okay, now we say that it is here now 6, so here it would be 8. Okay, to give a total of 14, the pH would be 8. Okay, the pH would be 8. Okay, so this solution still contains greater proportion of hydroxide ion, so this solution is still alkaline, but it is now a weak alkali compared to the this one. Okay. Okay, so if amount of hydrogen ion is 7, then amount of hydroxide ion has to be 7. That means both the amount of hydrogen ion and hydroxide ions are equal. The pH would be 7. Okay. So if the pH is 7, this means the amount of hydrogen ion and hydroxide ions are equal. That means the solution would be neutral. That's why theory says that if solution is acid neutral, then the pH would be 7. Okay. Now let's take pH let's take amount of hydrogen ion, as okay, no, 9. Okay, so what will be the amount of hydroxide ion? It has to be 5. Okay, so now the amount of hydrogen ion is greater than the amount of hydroxide ion, isn't it? So the pH would be amount of hydroxide ion, it should be 5. Okay, all right. So the pH would be 5, and okay, it contains amount of hydrogen ions more, but still it's not that much. Okay, the 9 and 5, they are so close. So it's an acid, but it's a weak acid. Now let's take it as 11. Okay, so here it would be 3. So pH would be 3. So amount of hydrogen is 11, amount of hydroxide is 3, so the pH would be 3. Okay, so this solution contains now more hydrogen ions than the hydroxide ions. So this is more acidic than the other. So this is a more stronger acid. Okay, now let's take it as 12. Okay, so amount of hydrogen ion is 12. So amount of hydroxide ion would be 2. So the pH would be 2. That means here the amount of hydrogen ion is much more greater than the amount of hydroxide ion. So this is a more stronger acid than the other solutions. Okay, now if the amount of hydrogen ion is 14, then the hydroxide would be 0. So the pH would be 0. That means pH 0 means amount of hydrogen ion is the greatest, that is very high. So that means the solution would be the strongest acid. Okay, so just keep this analogy in the mind, that total hydrogen ion and hydroxide ion must add up to give 14, and the amount of hydroxide ion is the pH what we are talking about. Okay. Okay, so pH identification is one of the best way to identify the nature of the acids. So now please start writing a note. At pH 7, start writing the note. At pH 7, the solution is neutral. If the pH is close to 0, then acid is very strong. If the pH is close to 14, then alkali is very strong. If the pH is close to 7, not equal to 7, if it is close to 7, then from the acid side, acid is weak, and from the alkaline side, alkali is weak. Okay, let me show it to you, like 0, 7, 14. So these numbers signify the hydroxide ions. So hydroxide ion is 0, so hydrogen would be 14. So this is acidic. I am writing AC. So hydroxide ion is 14, so hydrogen would be 0. So hydroxide is present, so this is alkaline. Okay, and this is neutral. Okay, so this whole side over here would be acidic, and this whole side over here would be alkaline. Okay, but here if you are close to 0, then this is strong acid region, and this is close to 7, this is weak acid region. So this is close to 14, this is strong alkali region, this is close to 7, this is weak alkali region. Okay. Okay, now that pH meters are not always so pH can be measured by using a meter called the pH meter, and pH meters are not always available. So we have certain we have a type of solution known as the universal indicator. Universal indicator. Universal indicator that would tell you the color and the nature of the that would tell you the nature of the solution as well as the strength of the solution. That means whether the solution is acidic or alkaline, or the if it's an acid, whether it's a weak or whether it's a weak or a strong acid, or if it's alkaline, or whether it's strong or a weak alkali. Okay. Okay. Now, what does the universal indicator do? Okay. So, universal indicator is something like universal means universe. So, it's type of universal color, the color of the universe, and you know that universe has got 7 shades of colors, and we call it like red, orange, yellow, green, blue, indigo, and violet. Okay, we call it roy j wave, or we call it wave gear. Okay, now just omit the I from here, then what you are left over here is the R, O, Y, G, B, V. Okay, so these are the colors of the universal indicator. Okay, now let's see that how the colors are matched with the pH. Okay, so red, specifically green. Green means pH 7. That means green has the color. Green would tell you that the solution is neutral. Okay, so R, O, Y. Okay, so here in the red we have 0 to, so from 0 to 2 you can say it as it's red. Okay, then from 3 to 5 we can say it as orange, and from okay, no, from 0 to 1.5 we can say it as red. Okay, from 2 to 4.5 we can say it as orange, or around it at 4.55, whatever it is. So, and from here, from 5 to 6.9 we can say it as the yellow, isn't it? Okay, these numbers can vary. You can just remember, like each color would tell you 2 pH values. Okay, in this manner you can keep it easily in mind. Like for example, if green is 7, green is 7. Okay, let me rub all of this. Okay, now if green is 7, then you know R O Y, like red would tell you from 0 to 2, yellow would tell you from 2 to 4, then orange would tell you from 4 to 6, etc., etc. Okay, so these can vary. The green is 7, but just keep this in mind as the way you like to keep it in your mind. All right. Okay, now VGY, G, beef. Okay, blue. So blue, you can tell it from okay, it can be 6.9, so you can tell it from 7.1 to 9. Then violet would be from 9 to 14. Okay, you can also call it as from 7.1 to 10, and this can be from 10 to 14, whatever way you like. it will not be a problem and you will get the full marks. Okay, the universal indicator, the employment of universal indicator is just would give you an estimate of the pH. Okay, it wouldn't tell you the accurate pH. All right. Okay, so what I prefer is that you would keep in mind that for each color you are getting 2 pH values, and the color appear exactly in the way as the rainbow. Okay, so from that sense, in the presence of indigo would be pretty good. Okay, you can keep indigo in your mind, no problem. So here blue, then indigo, like you can tell it is 9 to 11, and the violet from 11 to 14. Okay, that wouldn't be a problem. So universal indicator just give a quite accurate estimate of the pH of a solution, okay, when the pH meter is not available. And okay, so universal indicator and the pH values would tell you the nature of the solution, that whether the solution is acidic or alkaline, and would also tell you that if it's an acidic, whether it's a strong or weak acid, or if it's an alkali, whether it's a strong or a weak alkali. Okay, so like red, if it's red, then for sure it's an acid and it's a strong acid. If it's yellow, that means the solution is still acidic, but the solution has got weak nature, that means it's a weak acid. Okay, okay, we will differentiate between strong acids and weak acids later. Now let's go to just the identification of acids and bases, acids and alkalis. Okay, just the identification, not the strength. Okay, we have an indicator which is known as the litmus paper or litmus indicator, that also gives a red color in acid. Okay, red color in acid and blue color in alkali. Okay, blue color in alkali and red color in acid. All right. Okay. Okay. So now let's move on to the next phase. We have few more indicators like this, like litmus paper or litmus solution. We have few more indicators like this, like methyl orange. Then we have phenolphthalein. Then we have bromophenol blue, and then we have bromothymol and many other solutions like this. So if I go to the book, okay, strong and weak acids, formation of salt, I will talk about it later. Now let's look at some indicators of acids, and okay, here I get the color. Okay, so these are the colors of the universal indicator related to the pH. Okay, so now let's move on to the now let's move on to the topic of strong and weak. I mean strong acid and weak acid, and a strong alkali and weak alkali. Okay, so the concept of strong and weak came from acid means it should release or it should give the hydrogen ion, and alkali means it should contain hydroxide ion and it has to be soluble in water. Okay, so the strong and weak concept came from like so H plus ion is the indicator of hydrogen ion chemically, and OH minus ion is the indicator of hydroxide ion chemically. Okay, now if a compound is such that it can release or it can produce or it can what you say that it can initiate a large amount of hydrogen ion when it is dissolved in water. So large amount of hydrogen ion is a strong acid. The solution would be a strong acid if it produces large amount of hydrogen ion when it is dissolved in water. So if the amount of hydrogen ion produced is very large, so if the amount of hydrogen ion, we're calling it in the form of third bracket means the concentration of the amount. If the amount of hydrogen ion is very large, then we would call it that the solution is a strongly acidic solution. Okay, so the solution is strongly acidic, okay. But if the solution contains small amount of, so if the amount of hydrogen ion is small or little, then we would say that the solution is acidic. That's true, but it's a weak acid. Okay, now how do you understand from a chemical reaction that whether the amount of acid or the alkali is weak? Sorry, the that the amount of hydrogen ion is large or small. That means the acid is strong or weak. Okay, now chemistry says in a theory, chemistry says that if the amount of hydrogen ion is large, then the amount of hydrogen ion is only large when the giving or the dissociation of the compound is one way, or if the reaction of the acid or the giving of a hydrogen ion is one way. Okay, but if the giving of hydrogen ion, if the giving of a hydrogen ion is reversible, that means you give and then you take back. If the giving of hydrogen ion is reversible, if the giving of hydrogen ion is reversible, we would call that it's a then there would be a small amount of hydrogen ions present, because acids are giving the hydrogen ion and they are taking it back. Okay, so a small amount of hydrogen ions would be present if the reaction occurs in a reversible manner, and so we call it a weak acid. Okay, right, like if I say that HX is dissolving in water to give H plus and X minus, and this is a one-way reaction, so we would say that a lot of hydrogen ion would be present here, and therefore the solution would be strongly acidic. Okay, but if the reaction goes like this, that HX is being given to form H plus and X minus, but here look, the solution is being undergone in a reversible manner. Okay, so the amount of hydrogen that is produced will be very small, and so we would call it a weak acid. Okay, same goes for the alkali. If the solution dissociates in one-way reaction to give us a lot of hydroxide ion, we would call it a strong alkali. Strong alkalis are examples like we say sodium hydroxide, potassium hydroxide. Okay, all the group 1 hydroxides, they are strong alkalis. Okay, so the sodium hydroxide, they would dissolve in water to produce Na plus and OH minus, and it would be a one-way reaction. Same goes for the potassium hydroxide. Okay, now please write starting the note. If an acid or alkali undergoes one way or complete ionization, then we call it strong acid or alkali. And if the compound undergoes in the bracket, please write acid or alkali, undergoes a reversible or two-way ionization, a reversible ionization, then the solution would be weak. Okay, so we would call it a weak acid or a weak alkali. Okay, like here in this case, sodium hydroxide is a strong alkali. Okay, here the HX, this HX is a strong acid. Okay, now okay, don't stop the note. Let's look at some examples of a strong acid and weak acid, a strong alkali and weak alkali. Okay, okay, some strong acids are HCl, HNO3, H2SO4, etc. These are all very strong acids because they undergo one-way reaction or one-way dissociation to produce hydrogen ions. Okay, and the dissociations are all very complete. So H plus, okay, no, H plus. Okay, now let's move on to CH3 COOH. Okay, COOH, these are all organic acids. Any acid that contains COOH are called the organic acids. Okay, and you must keep in mind that all organic acids are weak acids. All organic acids, they are the weak acids. Okay, and you must remember that this hydrogen at the last of COOH is the acidic hydrogen. So this would undergo a reversible ionic a reversible dissociation or incomplete dissociation to produce hydrogen ions. Okay, so all organic acids are the weak acids. Okay, now let's go to the examples of strong and weak alkalis. Okay, all group 1 alkalis, all group 1 hydroxide are the strong alkalis because they undergo one-way reaction. Okay, one-way reaction. Okay, then potassium hydroxide, it's a one-way reaction too. Okay, and some weak acids, weak alkalis are calcium hydroxide, which undergoes reversible reaction to produce Ca2 plus and 2OH minus, and another weak alkali is ammonium hydroxide NH4OH, which dissociates to form NH4 plus and OH minus. Okay, so look, here we had reversible reactions, so these are the weak alkalis. Okay, okay, so these are the examples of strong and weak acids, strong and weak alkalis. Now let's move on to the reaction of acids and alkalis. Okay, now so I think you just remember that so acids are something that produces hydrogen ions. Okay, bases are something that gains or takes the hydrogen ions. Some bases are OH minus, O2 minus, and then CO3 2 minus. All right, and NH4 plus is an exceptional acid. Okay, NH4 plus is an when NH4 plus is mixed with water, it produces when NH4 plus is added with OH, it starts to act like an acid. In a reversible way, the NH3 acts like a base. How? Let's see. Okay, so I'm putting NH3 and NH3 and H2O. Please keep this reaction in mind. Okay, what happens here is that this NH3 takes one hydrogen ion from H2O, and so since NH4 is taking one hydrogen ion, so its H3 would become H4. So it now turns into NH4 plus, and one H has gone from here to here, so one hydrogen will be reduced from here, so we are left with OH minus. Okay, so look here, NH3 is taking one H from H2O, so here NH3 is acting as a base, isn't it, because it's taking hydrogen, and here water is acting as an acid. Water is not an acid, remember, water is not an acid, but it's acting like an acid over here. Okay, okay, now if we think of the reverse reaction, like NH4 and OH minus would react to form what? Okay, NH4 and OH minus, here what it forms, NH3 and H2O. Now what happens here? Tell me. Here it was H4, here it's H3. That means one H has been transferred from the NH4. And where it has gone? Look, here it was OH, but here it is H2O. That means this OH has gained one hydrogen. So this OH must have gained one hydrogen from the NH4, isn't it? So here the NH4 is acting as an acid, and here the OH is acting as a base, and you know that OH is actually a base. Okay, okay, now let's move on to the reaction of acids and alkalis. Okay, alright, so now to remember the reactions of acids and bases, just keep in mind the reactions, that if hydrogen, so hydroxide is a base, so it would take in the hydrogen from an acid and it would form H2O. Okay, now hydrogen would also react with hydroxide ions, oxide ions, to form H2O, but for that purpose we need two hydrogen ions. Okay, similarly hydrogen ions would also react with the carbonates to form the H2O and CO2. Okay, so that is the case. And one more reaction, it's a bonus, you can say, the NH4 plus and OH minus, and you know that OH minus is a base, so it would take hydrogen from NH4 and would form NH3 plus H2O. Okay, now what I would tell you is that you must record these reactions in your copy right now. You please pause the video and record the reactions in your copy. Okay, okay, now welcome back. Okay, so now let's move on into the detailed reactions of acids and bases. So okay, one more thing to say, that if hydrogen ion doesn't get any base, okay, if hydrogen ion doesn't get any base for its absorption, then what hydrogen ion would do is that it would take electron from the metals it would take electron from the metals and would get converted to hydrogen gas. Remember the electrolysis, isn't it? Okay. So in the case that when hydrogen ion doesn't get any base, look, it's an electron gaining reaction, and these electrons are from where? They came from metals. All right. So these electrons came from metals. That is, metals are losing them and losing electrons. Oil means it is oxidation. So metals are oxidized, and hydrogen ions, they are gaining the electrons. So gain of electrons, it is a rig. So reduction is gain. So hydrogen ions are gaining electron. So hydrogen ions are reduced. Okay. So when hydrogen ions doesn't get any base, please note it down from here. When hydrogen ion doesn't get any base, then the reaction becomes a redox reaction. When hydrogen ion doesn't get any base, the reaction becomes a redox reaction, and hydrogen gas is produced. Hydrogen gas is produced. Okay? And hydrogen ions gain these electrons from the metals. Hydrogen ions gain these electrons from the metals. Okay? So if hydrogen ion doesn't get any base, then it becomes a redox reaction producing hydrogen gas. Okay? Or on the other hand, if the hydrogen ion gets a base, then we call it an acid-base reaction or a neutralization reaction, and these are not, since hydrogen ions are getting bases, so these are not redox reaction, and we call them either acid-base reactions, or we call them the neutralization reactions. Okay. Okay, now let's move on to the examples. Okay, so for example, I say sodium plus acid, sulfuric acid, for example. So it's a metal plus acid. Okay, all right. So think of this hydrogen ion now, and is there any base present here? Base means oxide, or 2 minus, or hydroxide, the OH minus, or the carbonate, the CO3 minus. Is any base present here? No, not at all. So the hydrogen ions from the acid will not get any base, so it would be deposited as what? Okay, so it would be deposited as, okay, let me write the reaction again. Sodium plus H2SO4. So hydrogen ions is not getting any base over here, so it would be separated as hydrogen gas, and the rest of the acid sits with the metal like this. Okay, so this is what we call the salt. Okay. Now, so what is a salt? Salt can be defined in many ways. Please note it down. The definition of salt. Number one, a salt can be the ionic product, the ionic reaction product more accurately. Salt is an ionic reaction product of the reaction between acid and bases. Okay? Salt is the ionic reaction product of the reaction between acids and bases. Or salt can also be defined as something that cannot gain or release hydrogen ions. That means it doesn't gain or it doesn't release hydrogen ions, and it has to be ionic. Okay, so salts are ionic compounds that cannot gain or release hydrogen ions. Okay, so this is the second definition, and the first definition was it is the ionic product of the reaction between acid and base. Okay, so here this is the salt. And okay, so this reaction there was no base, so this is not an acid base reaction. So this must be this must be a redox reaction where hydrogen is reduced. Okay, hydrogen is reduced and the metal is oxidized. Okay. Now let's go to another example. For example, I say potassium oxide plus H3PO4, the phosphoric acid. Okay, so here we have the hydrogen from the acid, so these will be released because these are the acids. And here we have a base. Look, the oxide. Here we have a base, the oxide base. So the hydrogen ion will be gained by the oxide bases and form H2O, isn't it? So the hydrogen ions. So okay, wait. So the hydrogen ions are combined with the base, the oxide base, to form H2O. So we are left with what? We are left with potassium and phosphate. So let's write the formula. So it would be K3PO4. Okay, and how to balance the reactions you are already taught, and if you forget this or if you haven't looked at it, please look at the reactions balancing video. And the content of the title of the video was chemistry, the all level chemistry balancing chemical reactions. Okay. Okay, so now let's move on to another reaction. For example, I say the CaCO3, the calcium carbonate, reacting with HCl. Okay, so HCl is an acid over here. Here is the hydrogen that will be released. Okay, and here there is a base, there is a carbonate base. Okay, so here the hydrogen ion will be accepted by this base, so this would no more be a redox reaction. Instead, it's an acid-base reaction or a neutralization reaction. And just remember that when the carbonate takes the hydrogen ion, it forms CO2 and H2O. Okay, so from here the hydrogen ion and the carbonate ion, they have already reacted, so we are left with calcium and chlorine. So let's put this all together. It will be CaCl2. Okay, and you already know, and you please to balance to know how to balance a reaction, please look at my reaction balancing video. Okay. Okay, so let's move on to some other reactions, like okay, zinc carbonate, that means the metal carbonate, plus, for example, I say H2SO4. Okay, so metal carbonate plus sulfuric acid, that means the metal carbonate plus acid. Now here is the acid, it's an acid, so it will release the hydrogen ions, and here is it accepted, that is the base, the carbonate. Okay, so the carbonate base will accept the hydrogen ions from here and would form CO2 and H2O. Okay, this carbon dioxide is a gas, so that's why it sometimes says that when metal carbonates they react with acids, they form carbon dioxide. Okay, so the carbonate and the hydrogen has already reacted, so this part has reacted, so we are left with zinc and SO4. So let's put the parts together, it's ZnSO4. All right. Okay, so that's why when a metal carbonate reacts with an acid, we get salt plus carbon dioxide and plus water. Okay, before I will tell you that not to memorize the reaction, just to understand that how the reactions are working. Okay, now let's go to one more reaction. It's a reaction between any ammonium salt. For example, we are using ammonium chloride reacting with an alkali. Okay, reacting with an alkali. Okay, so look, here we have OH, which is a base, isn't it? It accepts the hydrogen ions. And here we have NH4, the H part, which acts like an acid. You know that NH4 acts like an acid by giving one hydrogen ion, isn't it? So what would happen is that one hydrogen ion would get from here to here, and these two part would form H2O, and the OH turns into H2O, and the NH4, since it's giving one hydrogen from here to here, so H4 would turn into NH3. So what we are left with is the Na and Cl. So put NaCl together. That's why the theory says that when, please note it down, that when any ammonium salt like NH4Cl, or it can be any other ammonium salt, reacts with sodium hydroxide, we get salt, water, and ammonia gas. And ammonia gas is a pungent gas. Okay, it's very pungent. It's an alkaline gas. So these are the things. These are the few acid-base reactions. So here we had an acid. Here we had a base. So this is not. So this is an acid-base reaction. So this is not a redox reaction. You just remember that no acid-base, I repeat, no acid-base reactions are ever redox reactions. Okay. Okay, so that's the end of the acid-base, the basic section. Now let's move on to the salt section. The salt and the preparation of various types of salts. All right. Okay. First of all, before going into the detailed methodology of producing various types of salts, we must need to know, or we must have ideas about soluble salts that are soluble and salts that are insoluble. Okay. Please start noting from here. Okay. Now you might have noticed that every time I say that please start noting from here, I take a screenshot so that in the comment section or anywhere I could mention the time of taking the notes. Okay. Okay. Now let's talk about the set 1 salts. Okay, this set is entirely named by myself. All right, don't take it that much seriously. Okay, so set 1, say the salts in set 1, they are all soluble in water. All the salts in set 1, they are all soluble in water. So set 1, sorry, so set 1, all salts are soluble. Okay, all salts are soluble and no exception is here. All salts are soluble with no exception over here. And the thing is that the salts in this group includes like number 1, so we say that all sodium salts, then all potassium salts, okay, then all ammonium salts, then all nitrate salts, then all nitrate salts, all these salts. Okay, in fact, all salts of group 1 of periodic table, they are all soluble in water without any exceptions. Any salt, any compounds of these things, the sodium, potassium, ammonium nitrate and group 1, they are all soluble with no exceptions are there. All right. Okay. And how will you remember this? Okay. I'm sorry about the fact that English memes in this case is not design. I couldn't design the English meme. Let me tell you the Bangla. So I used to say that ammoni একটা নাক. Okay, ammoni একটা নাক. Okay, now let me tell you what goes for what. Okay, so the ammoni stands for the ammo stands for ammonium. Okay, the ni stands for the nitrate. Okay, so ammo stands for the ammonium and the ni stands for the nitrate. Okay, now acta means 1, so acta stands for group 1. Okay, and you know NaC means sodium and potassium, so that's all. NaC, these are also group 1, so I'm also coloring them yellow. Okay, so ammonia acta NaC. Ammo means ammonium, Ni means nitrate, acta means group 1, and Na and K means sodium and potassium, which are also group 1 elements. Okay, so ammonia acta NaC, so these compounds are all soluble in water with no exceptions at all. Okay, now let's move on to set 2. Okay, so set 2, now in the set 2, the thing is that in set 2 all salts are set 2 is okay, firstly set 2 is about the solubility of sulfates. Okay, the solubility of salts that contains the sulfates. Okay, so here the thing is that, please write it down. Okay, so you see here a picture of a boy who is bent, isn't it? He's not standing straight, he's bent. So in Bangla we call it so it's a bent boy. So boy means sele in Bangla and bent means baka. So we call it the what should I say? We call it the baka sele. Okay, baka sele. So Ba stands for barium, Ca stands for calcium, Se stands for it's not selenium, it's just to make a short rhyme. Se stands for silver. Okay, it's a silver or silver, and Le stands for the lead. So Baka sele. So Baka sele is barium, calcium, silver, and lead. Okay, so what does it mean? This actually refers the fact over here that, can you please write a note, or okay, start writing the note, that all, oh, you are already writing note, right? So all sulfates are soluble, please write it down, that all sulfates are soluble except Baka sele. That means barium sulfate, calcium sulfate, silver sulfate, and lead sulfate, they are insoluble. And except this, all sulfates are soluble. All sulfates are soluble. So all sulfates are soluble except the Baka sele sulfates. Okay, so these are set 2. Now let's move on to set 3. Okay, let's move on to set 3. Set 3 is for the chlorides, the bromides, okay, the iodides. So here set 3. So in set 3, just write that all chlorides, bromides or iodides are soluble. All are soluble, all except only the Sele, that means silver and lead. So, in the sulfate we had Baca-Sele sulfates are insoluble, and here we have Sele, chlorides, bromides, iodides are insoluble, and all chlorides, bromides, iodides are soluble. Okay. So, if you say silver chloride, silver bromide, silver iodide, all of them are insoluble. If you say lead chloride, lead bromide, lead iodide, all of them are insoluble. Okay. Now, let us go to set 4. Okay. So, set 4. Okay. So, set 4 is for hydroxides, the oxides, carbonates, etc., for all of this. Okay. Okay. So, and also, okay, not required. So, set 4 is for the hydroxides, the oxides and the carbonate. That means you can say that set 4 is for the bases, okay, because these are all the bases. All right. Okay. Now, let us see. So, please write the note that all hydroxides, oxides and carbonates, they are all insoluble. All right. All oxides, hydroxides and carbonates, all of them are insoluble except if they are combined with set 1. Okay. That means if set 4, if the bases are combined with set 1 substances, then they are soluble, because you must remember that in set 1 everything is soluble and there are no exceptions. It does not matter that what you combine with them. Okay. So, set 4 contains the bases, the oxides, hydroxides and the carbonates, and all oxides, all hydroxides and all carbonates, they are all soluble, they are always soluble. Sorry, they are always insoluble, but if they are combined with set 1, then they become soluble. Like if we say, for example, magnesium carbonate. Okay. So, this is insoluble because magnesium is a set magnesium is not a set 1 compound in a set 1 substance. But if you say sodium carbonate, sodium, you remember that NaC, isn't it? NaC, or it's a group 1 element. So, this sodium carbonate is soluble because sodium is present in set 1. Okay. So, these are the solubility of salts, and the preparation method of the salt would base on the solubility of the salt. Okay. Okay, so today we will finish this class by one more reaction, which is also a type of acid base reaction, which I have forgotten to mention it earlier, and we are left with very small part of the acid and base the acid base salt chapter, which is the preparation of salt. We will finish this chapter by next video. So, let us discuss about the rest reaction that I have left. Okay. So, the reaction is that, okay, stop writing the note and now stop writing the note and now start writing the note again. Okay. When a hydroxide reacts with water, what happens? Okay. You remember that hydroxide is a base, isn't it? So, it would like to take hydrogen ion from elsewhere. So, what will happen is that this hydroxide ion will take a hydrogen ion from water. No, I'm sorry, not the hydroxide. I was going to talk regarding oxide. Okay. The oxide is also a base, it's a very strong base. So, it would prefer to take hydrogen ion from elsewhere. Okay. So, it would take hydrogen ion from water if it is combined with water. So, to form OH, minus, and one hydrogen goes from here to here. Okay, so we will left with one hydrogen over here. So here we will get OH, another OH. Okay, so when, this is very important, when any oxide, any ionic oxide reacts with water, we get what? Hydroxide. And how many hydroxides? We get 2 hydroxides. Okay, let's look at some examples over here. Like I'm saying sodium, okay, I'm saying sodium hydroxide plus water. Okay, so here hydroxide is a base, so it will take hydrogen from here, and so no, I'm doing the same mistake again, same mistake, I'm so sorry. So sodium oxide plus H2O, so it will take hydrogen from here to form hydroxide, so hydroxide. Okay, and this water will also form another hydroxide, so we will get NaOH and NaOH, or better we write here 2 NaOH. Okay, so when any ionic oxide is dissolved in water, we get what? We get hydroxide. Let's look at another example. So calcium oxide plus water, although it's not that much soluble in water, it's quite insoluble, but still some will be soluble. So oxide will take hydrogen and from hydroxide, so we will get 2 hydroxides, so CaOH 2. Okay, calcium has got the valency of 2. Okay guys, so that's all for the acid base salt chapter of this week. We will finish the chapter by the next video in the next week. Okay, so before that, today I will be giving you the worksheet of acid base and salt, and you have to complete it by Wednesday, and we will discuss about it on Wednesday. And from the next week we will have classes in 3 days, the Saturday, the Monday, and the Wednesday. Okay, so guys, we will have 3 days discussion over Zoom. So I think not, I believe that you will complete the worksheet, and we'll be discussing the problems of the videos in the classes in the Zoom. Okay, till then guys, goodbye.